Awesome. Okay, so since I had computer trouble, we started with 1 through 3. Let's go ahead and let's try out these problems. So I want to simplify, but you only can combine like terms. So if I have a root 2 and a root 8, different things under the root. So what I would like to do is simplify the radical. It would be great. Instead of saying root 50, if I could have, blah, blah, root 2, right? If I could write it as a root 2, I could combine them. So ideally, I want to simplify this radical. Okay, so let's take 50 and let's find its prime factorization. Okay. 25. Oh my gosh, that was not the right way. Okay, perfect. Okay, let's take 50. He says 25 and 2. He said 25.
5 and 2.
Huh?
5 outside, 2 inside.
Yes, so the way we figure that out is instead of saying root 50, I could instead write this as root 25 times root 2, because if it's inside, if we're multiplying two radicals, instead of writing, rad 25, rad 2, you can instead say rad 25 times 2, which is also 50, so it's exactly equivalent. And so this means it's just going to be 5 root 2, because the square root of 25 is 5. Okay, so I have 3 root 2 plus 5 root 2, and then I have to deal with this root 8. So, rad 8. So let's see what 8 is 4 times 2. 4 is a perfect square. That's why I'm pausing there, because it's a perfect square. If you wanted to go further, you're like, okay, I have 2 and 2. Since we are having a square root, we're looking for anything that's repeated twice. So you could write rad 8 as square root 4 times square root 2, or you could just go straight to saying 2 root 2. So I'm subtracting 4 times what rad 8 was, 2 root 2.
That's 4, 8.
So you have to take negative 4 times 2, so it's minus 8 root 2. And then it's kind of like if we had 3x plus 5x minus 8x. You combine like terms because we all have rad 2, so you just have to combine the coefficients that are in front. So 5 plus 3 is 8 minus 8. Ooh, answer 0. All right, did you guys get a chance to try number 2? No response. Let's try it again. Did you get a chance to try number 2? You can be like, no. That's also acceptable. I'm literally just asking you. So no? No? Okay. Well, we're going to do 1 through 3, and then we'll go on with the lesson. So I'll give you about 5-ish seconds. Give it a start now that we've already done a problem. Right. Instead of saying root 8, I said 2 rad 2. But this portion right here, this is what root 8 is equal to, but then I have to multiply by this 4. Yeah. Cool. All right. Oops.
These ones, like 2 and 3, seem pretty simple, like compared to like the examples that they gave us.
What? Oh, it's simple compared to the examples.
Yeah, like I was looking at like example 1 and stuff, and they seem a lot more complicated than that.
Yeah. Well, I mean, these are the beginning. Normally, it's easier in the beginning, which is why I tried having you guys like try it out. Okay, so we need to write these all in terms of like fully simplified radicals. Kind of. I just want to see, okay, root 20 can be written as, what was the simplest form?
2 and 5.
So 2 root 5, because root 20. Is it helpful if I write it out this way? That's how we get 2 root 5. Root 125. 25 times 5. Okay, so this is just going to be 5 root 5. And then minus 45. Okay, so 9 and 5. So square root 45 is square root 9 times root 5. 3 root 5. So minus 3 root 5. 2 plus 5 is 7. 7 minus 3 is 4, so I have 4 root 5 at the end.
Wait, what was your final answer?
0.
So you don't do anything with the root 2?
Well, the coefficient was 0, because if you take 3 plus 5, that's 8. 8 minus 8 is 0, so 0 times root 2 is just 0. Yeah. Cool. Ideally, this is a nice warm up. And then we'll try number 3. Move it over a little bit. Okay. Sorry, I'll go back a sec. If you have not given a shot to number 3, now that we've done 2 examples, try it out. Let's go. Are we getting better with these type of problems, the ones we're doing right now? Are we okay with these? Because if we can just, okay, ideally, it's a little overwhelming because there's so many things to remember. So if we break it down and we learn the different types of problems, and just do lots of examples of each one, like you'll see the pattern, right? That's the goal. That's the goal. I want you to do well this chapter. I'm trying to slow it down a little bit. We got this, right? You just have to have a positive mindset. Honestly, that's a lot of what math is. It's hard. You want to give up. What the heck is going on here? But like, we're good. We can do this.
When is our quiz or our next quiz?
If you look at your lesson plan, it says. All right. So today is 2/7. We have 6.7 after this lesson. Then we have a day review, and then we have the chapter 6 test on the 13th.
Which day next week?
Thursday. So it's last period. So plan on coming in during lunch on Thursday if you have extra time, because you don't have school the 14th. And then sophomores leave. Sit up, Talia? Right. To faculty and service. Or Monday. Kind of nice.
We have school this Monday, right?
Nope, not this weekend.
Oh.
Next weekend. We're talking about the test on the 13th.
Oh, we have school this Monday.
Yes,
Okay.
yes. We're talking about the test, which is the 13th. Context clues. And then I said the reason why it's on the 13th. And we have to do, gotta have the extra time before you actually start taking the test, is because you won't have school the following and sophomores leave. So you have a whole week of school. It's a week from yesterday. It's when your test is. You have the practice test already. The solutions are posted online. Okay, 10 minus 3 is 7. 7 minus 5. So this is just 2 root 3. How do you feel about these problems so far? Okay, yeah. If you're like iffy, it's better than being like, what the hell is going on? This is progress, okay? Just remember, every day, you just got to do a little bit of progress. Whenever you're overwhelmed, anything is better than nothing, okay? Anything's better than nothing. We just got to try to understand this as best as we can.
The practice test for the next one?
I did already. Yep. The day you took the quiz, and everyone got their quiz back. The only thing I still have for you guys is the homework that was with this quiz. I'm going to try to get it ready for you on Monday.
I think I have.
I gave back 5, 7, 5, 8 homework just now. I try to grade the tests and quizzes as soon as possible. It just takes me longer with homework. Yeah. Okay, so, oh my gosh, we learned this yesterday. We know this, right? Square root of x is the same thing as x to the 1/2 power. We learned Wednesday? Yeah, okay, well, guess what? I kind of taught you this lesson already. Rational exponents, literally exponents that are ratios, exponents that are fractions. So if I say 27 to the 1/3 power, it's just going to be the cube root of 27. Or you can go the other way and say, okay, if I have 27 to the cube root, it's just 27 to the 1/3 power. Because I felt it would be better for you to know this. Maybe next year I'll move this section to be the first one. That would probably be a better idea. Okay. So 16 to the 1/2, instead of saying 1/2, you just write it as square root of negative 16. And then you know what that is. That's just going to be 4i. Okay, cool. So write in radical form. So here I have a to the 1/5 power. Try it. Try it right now. You know how to do it already. Once you show me you know how to do it. So, what do I do? So I have a radical, a is under, and what number goes here? 5. Ah, perfect, 5th root. That's it. Yeah, look at you go, successful. Ready? Let's do B. Let's do B. Ooh, this one's a little harder.
What was the first one?
5th root of A. A to the 1/5 power, same thing as 5th root of A. Right? If I have, 3rd root of X, this is just going to be X to the 1/3. How about 7th root of T? This is just T to the 1/7. Okay, sweet. See, you guys are doing well. What was the trick I told you? What if I don't just have a 1 as the top? Remember? Top dog.
In the house.
Top dog in the house. So, top dog is in the house, right? The dog house. The radical. So this top one is inside the radical. Ah, so this is just going to be the 4th root of D to the 7th. Right? Top dog in the house.
And they could go to it one time, which is D to the 3 inside, and then just D outside.
Perfect. So I could write that way. I also could, as he was saying, if I rewrite 7/4, that's 1 3/4. So an equivalent expression would be D times the 4th root of D cubed. Because technically this is D to the 1st, and this guy right here is D to the 3/4. If you add 1 plus 3/4, you get 7/4. So originally this problem, I was trying to get you guys to understand top dog in the house, but also this is what we have been using for our last section. So it would make more sense for this section to go first. Next year, I'll know. I don't know why I didn't do it this year. All right, let's try it. Write this in exponential form. Ooh, I have the 8th root of C. What would this be? C to the 1/8. See, you guys are doing well. Doing excellent. C to the 1/8 power. Okay, think about this one. A little harder. What do you think?
Is the negative power?
C, I don't know why this pen is so fat. Let me, one sec. Okay. C to the negative 5/3. And normally, we don't want negative exponents. So in order to fully simplify it, how would I write this? I just, to make it a positive, 1/C to the 5/3. To get rid of the negative, you put on the other side of the fraction.
So are we doing that on the test?
This is fully simplified. This is what you must do. You can't end up with a negative exponent. You must get rid of the negative of the exponent by moving the variable to the other side. So this is what we have been doing for a chapter and a half now. Okay, rational exponents. Rational exponents, okay. So for any non-real numbers, any non-zero number b, any integers x of y, they're greater than 1, blah, blah, blah. Okay, so the key here, if I have something like 27 to the 2/3 power, okay, this is top dog in the house. So this is the same thing as saying 27 squared, the cube root of 27 squared.
27.
What? Yeah, right here, 27. 27 squared. Or, right, because you could do 27 squared and then take the cube root, or you could take the cube root of 27 and then square it.
Anything to the second power inside of that little thing just itself.
No. It would have to be a square root, the square root of something squared. This is a cube root of something squared. It's not the same index, not the same number.
That makes sense.
Okay. So let's go ahead and let's evaluate this. So I have 49 to the negative 1/2. Okay. So this is exactly, let's do what Isabella was saying to do. So I have 49 is just 7 squared. 7 squared to negative, do I want to solve it this way? How did this want me to solve it? Blah, blah, blah. Have it in the first power, write it as Okay, do this, and then square. Okay. Okay. This is how your book wants me to solve it. So I have 49 to negative 1/2. This will be the same thing as 1 over 49 to the half. We know what this is. This is just 1 over the square root of 49. What is the square root of 49? 7. So this is just 1/7. This next one's a little more difficult. So the reason we're doing these examples is try to make it easier when you're computing. That's the idea. So I could write 32 as, or 32 to the 2/5. I could write it as the 5th root of 32 squared, or I could write it as the 5th root of 32 and then squared. So it depends what you're trying to do first. Are you trying to square 32 first and then take the 5th root, or do you take the 5th root and then squared? So here, since it's both, it is equal in the order of operations, right? Taking the 5th root or squaring 32, they're in the same level of order of operations. They're both exponents. That's why it doesn't matter which way you do it first, because you get the same answer. Talia, sit up. All right.
Why do you do that for the first B then?
First B.
So since you're doing that, does that mean that it becomes 10? 5? No.
For this B? Well, it's not a number, so I can't actually simplify it at all. It's just D is a variable. Versus, since this is a number, we know what the 5th root of 32 is, right? What times itself 5 times is 32? This tells me no. 2.
Yeah, I know.
Because 2 times 2 times 2 times 2 times 2. Because times itself 5 times. Times itself 1,
Just
2,
divided by
3, 4.
Oh,
No.
no, wait, not that.
No.
Sorry.
Times itself 5 times. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32.
Sorry.
Right, and I showed you guys how to do this. So, this is the portion where you're like, okay, cool. You could do prime factorization as well. Prime factorization shows you 5 2's. So this is going to be 2. Right? All I did was, instead of saying 5th root of 32, I put in 2. And what is 2 squared? 4. Okay, that's our answer. Now we're going to simplify expressions using all the algebraic operations that we have learned. Sorry, do you need more time for this?
Yeah, you can get the 2.
5th root of 32. What times itself 5 times is 32. 2 to the 5th is 32. So the 5th root of 32 is 2. All right. And then the part I highlighted, instead of saying 5th root 32, I said 2. And then that squared is going to be 4. All right. So we're going to combine using all the things we know. Oh, look. We're back to chapter 5. I have a same base. I have a y times a y. What do I need to do with the exponents?
Multiply.
Combine them by adding. So I have 1/7 plus 5/7.
No, 4/7.
I'm sorry, I was giving the answer.
4/7.
4/7. So this is just y to the 5/7. How do I write that in radical form?
7 and times 5.
7th root of y to the 5th. Top dog is in the house. Top guy stays under the radical, right? The radical's the house. Do we understand how to add fractions? Or you add the top, but they have to have the same denominator? All right, let's try B. So we're trying to simplify this. So first, ooh, I got a negative exponent. What do I need to do? Put it under 1. Okay, so now I have x to the 2/3. How do I rewrite this? 1 over cube root of x squared. Right, the bottom guy always goes out front. The top stays under the radical.
So we no longer put I?
We didn't have an I. We haven't dealt with, what do you mean? There was no I necessary for these first two.
Okay.
Do we need to zoom in on any of them? Here, I can zoom in a little bit. Okay. All right, let's try C. Ooh, tricky trick. This is crazy. So 6 root of 16. Okay. So it'd be nice to simplify this a little bit. Yeah. So let's just write these instead of having the radicals in terms of, something to an exponent. So this is 16 to the 1/6 power over 2 to the 1/3. Okay, thanks. But,
You still
it would be
simplify.
nice to use rules of exponents.
4 times 4.
But the only issue is, I would need to have the same base. I have a base of 2 on bottom. Can I rewrite 16 as 2 to some power?
2 times 2 times 2.
So I could have the same base, so I can use rules of exponents.
No.
So 2 to the 4th power is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16.
Oh yeah.
Yeah, so I can instead write this as 2 to the 4th power, and then I still have to the 1/6, over 2 to the 1/3 power. Ooh, look what I have here. I have an exponent to an exponent. How would I simplify this? Multiply. So I have 2 to the 4/6, right? 4 times 1/6 is 4/6. What is 4/6 equal to? Can I simplify? 2/3? 4/6 is 2/3. If I multiply the highlighted part, 4 times 1/6, right? 4 times 1/6 is 4/6. And then if you want to simplify the fraction, 4/6 is just 2/3. Okay. So here, this exponent is going to be 2 to the 2/3. And this is over 2 to the 1/3. Wait, we have the same base. We can use rules of exponents. Yeah, they both have base 2. So this is just going to be 2 to the 2/3 minus 1/3. 2 to the 1/3, aka the cube root of 2.
Always have to find out what 2 times what,
The reason I replaced 16 with 2 to the 4th is because I want to use rules of exponents. Because I have a base of 2 on bottom, it'd be nice to have a base of 2 on top so I can simplify the exponents.
Oh, and you don't actually divide the 2's.
No, I use rules of exponents. I have 2 to the 2/3 on top, 2 to the 1/3 on bottom. Same base, you subtract the exponents. Okay. Shall we continue?
Like what?
No?
Well, what happens to the
Hold
2?
on. Ruby had a question?
Yeah, why?
Oh, I get it.
The
Okay.
2 turn into a 1. You divide 2 by 2.
But it's not 2 by 2. It's not 2 to the 1st over 2 to the 1st. It's 2 to the 2/3 over 2 to the 1/3.
I get it. It's negative, so you're just moving it back up.
If I had
Yeah.
If I had x to the 2 over x to the 1, you would say, oh, this is just x to the 2 minus 1, right?
And then
X to the 2/3 over x to the 1/3. Like, okay, then this would have to be x to the 2/3 minus 1/3. Difference is this is an x here, in our problem it's a 2. So it's weird because it's a number as the base, but we can still use rules of exponents. All right. Shall we? Let me think. Do I want to try this one? Yeah, let's do it. So I'll just write this as the 6 root of 4 times the 6 root of x to the 4th.
Why don't you just simplify it to like 2x to the second times.
So what did you do there?
Well,
You
first,
divided. You took half of 4 and half the exponent.
Well, it's in a, you have to, what is the box thing called?
Radical?
Yeah, it's in a radical, so, you know, if that was just 4 alone, it would be 2, and if it was x to the 4th alone.
If it was, but this isn't just square root, it's the 6th root.
I know, so first I did that, and I got
If it was
2x
just
to
square
the
root,
second.
if it was square root this, I'm sorry. If this was what the problem was, it would be 2x to the second. But because there's a 6 right here, you can't, it's not going to be equal to that.
I kept that in mind, but I did like 2x to the second, parentheses 1 over x, or 1 over 6, but that's.
No. It's okay. Question? Yes.
Oh my god, I just came up with something that was crazy and kind of works.
So wait, I can write 4 as something to the power. 4 is the same thing as 2 what? 2 squared? Ugh. Huh? 2 squared. 2 squared is 4. Yes, no, I don't know. You guys are giving me crazy looks right now. Instead of saying 4, I can write 2 squared. And now that I have to the 1/6 power, I can combine them, and I'll have 2 as my base. And over here, I can write x to the 4/6.
You have to like break it down.
I'm trying to break it down for you guys because I am just getting deer in the headlights from every single person here. So I'm trying to gradually show you what we're doing.
Kind of making it more complicated than it needs to be.
Thanks. Appreciate your comment. Yeah.
Why can't you just simplify the 4? Like, why doesn't the 4 become 2? And then
Because it's not square root. It's a 6th root.
So you multiply it.
Kinda like
So
doing
instead
4
of saying
6.
4, I said 2 squared. And now that I have an exponent to an exponent, I can write this as 2 to the 1/3 times x to the 2/3. Okay. So what this is going to be is the cube root of 2x squared. So you were close with the 2x squared. It's just that it's all in a cube root, not a 6th root. Now the reason is because this is the same thing as so they both of these have fraction as the exponent. They both are over 3. So I bring the 3 in front to say, oh, cube root. And then I'm left with the top exponent. So 2 to the 1st times x squared.
You just simplified it.
Yes. Yes.
Ooh, can I share something that I found was really cool?
Is it relevant?
Yes.
No.
It's super cool though.
Question. Hold on. Him? I'm going to check my email. Don't worry. Yeah. You have a question?
This is cool.
How many more problems do we have? 2 more. Okay, cool. Oof. So I'm going to cross out these next 2 because I copied them straight from Algebra 2 and that's not what we're going to do. So we're going to spend the last like 20 minutes of class going over just more examples. Coolio? They
the last 2.
shouldn't be. If they are, you need to email me and let me know.
Last night, some of the homework questions, like one of them was like something that was an example of it.
What was the problem?
It was, I don't remember the problem, but it was
Like, just what was the problem? We can do it together and I'll see if it's something I wanted you to do. I thought I was careful when I selected the problems.
it was 11 on 6.5.
No, I want to know what the problem is, not the number. Like, what is it actually?
4 plus 2 square root 5, and then that's in parentheses, and then 3 square root 3 plus 4 square root 5, and that's all.
Ah.
Don't these y's cancel out because 1 is underneath?
Okay, so we could do that. Yeah. Yeah, you just FOIL. What's wrong?
Doesn't the y on the bottom cancel out? because
No,
it's underneath?
no, because it's y to the 1/2 plus 1 and y to the 1/2 minus 1.
So 1's plus 1, so since 1's minus 1.
No, they don't cancel because you have to do the subtraction before you do the division. Order of operations. Okay, so this one is like fine. You just FOIL it. So first, you just have to go in order, right? First, 4 times 3 root 3 is just 12 root 3. Outer 4 times 4 root 5 is 16 root 5. Inner 2 times 3 is 6, and then you times root, and you multiply what's under the radical, so 5 times 3 is 15. So if I have 2 root 5 times 3 root 3, this is the inner. First, outer, this is the inner, we're multiplying. So what you have to do is you multiply the coefficients together, and then what's under the radical. So only if you're multiplying the radicals can you multiply what's inside the radical. And then last is the 2 root 5 times 4 root 5 is going to be 8 times root 5 squared. Oh, okay. Or another way to say it, okay, let's multiply what's under the radical. Root 25. What's root 25? 5. So instead of saying root 25, I say 5. What's 5 times 8? 40. So we have 12 root 3 plus 16 root 5 plus 6 root 15 plus 48. Yeah. It's doable. If there's any other like questions like that, just let me know and we can do them in class. Or if I'm like, oh, you know what, I messed up, I can cut them in. But like as you go through your homework, just like let me know. Instead of looking at, you know, online at Photomath or, oh my god, not Slacker, but Slater. Instead of just copying straight from there, people should email me instead. Because there was 15 people out of the whole, both my sections of intermediate, that copied the same problem. And I know it's from Slater because Photomath did it a different way because I check. And I'm like, okay, well, why don't you just email me if you don't know how to do it, you know? Like, why copy? Because it's not going to help you with your test. And it's not the way we learned it. It's not the way the book answers were. And it was this random girl on Slater who totally did it weird. So, cool. Nice. So there's a couple problems. Let's go over... What? I crossed them out? Yeah, I crossed out E and F. Yeah. And so if there's a problem like that on your homework, then let's not do it. Just let me know. Because, for instance, this one, I think you can foil. You know, you can do it. E and F, I'll make sure there's not one like that on your test, you know. Now, if it was, like, if instead of, like, multiplying instead of adding 1 and negative 1, if we're, like, multiplying, it would be better. So, like, this one could be okay to do. Because this is just going to be c b to the third over c to the 1/2 b to the 1/3. Like, it's not too bad. You just have to subtract the exponents, okay? So I have c to the 1 minus 1/2, b to the 3 minus 1/3. So you get c to the 1/2, b to the 2 2/3. So it's not pretty because now we have different denominators. Literally, square root of c times the cube root of b squared, the b squared in front, right? So this is not pretty. This is how you do it. I don't expect you to be able to do this one because what I'm trying to do is not have you have. I don't want you to have two different indexes for your radicals. I'm trying to limit it so it's like, oh, they would all be under the same radical at that point, right? So that's my goal. I'm going to try to show you this stuff because I got to, but also cut it where I really don't need to. So I would not want to give you this problem because they're two different. This is index 2, this is index 3. Are there any other examples? Do you want like 12 minutes work on homework and Alex instead? Or more problems? Okay, so you work on Alex and homework instead. Yes.
Yeah, I think we do 1 through 3.
1 through 3.
Or 1 through 4. I like the
What page?
Just like, just whatever.
66. What page? 20. What numbers? Okay. Sure. Yeah. Definitely 1 through 6. These are good. This is like the level I want you to be able to do. This first one, what is 11 to the 1/7? Yeah. We just want to express it in radical form. So if I wanted you to like actually evaluate it, you would have to put in, 7th root of 11 into your calculator, but I just want radical form. What about this next one? Cube root 15.
5. No.
Nope.
5 times 5 times 5.
It's 125, not
That's not it.
15. Ah, okay. So I want the
3.
cube root.
300 and 300.
Oh, sorry. The square root of 300 cubed.
We don't need a 2 there, right?
No. I just want to make sure you knew where it came from.
But if you do 2, does it matter?
No, because it's not wrong. It's just we don't normally write it, you know? Like normally you don't write your middle name. Ah, whatever. It's still there. It's still right, you know? What? What? If you, yeah, if you don't have a number there, it's assumed to be a 2. Ooh, what is this one?
2.
47 is a prime number. Wait, what's it wanting? The radical form? Did I delete the directions? Or write each radical in exponential. Okay, so 47 is the 1/2.
Oh, the answer?
Yeah.
You don't like.
No, that's it. Because 47 is prime. I can't do any more of it.
Next.
Okay. Okay. Can I reduce any of these? So, do you want me to show you a trick, or do you just want to, like, go the way we have been doing? Okay. What is 5 minus 3? 2. So, let's go step by step. Can I reduce 3 anymore? It's like, you know, do I have a cube root? No. So I leave it under the cube root. Okay. Okay. Then, what is 5 minus 3? 2. And I took away 1, right? Yeah. Because how many times can 3 go into 5? 1 and 2/3 time. That's literally 5 divided by 3. What is 2 divided by 3? 2/3. Ah, then I gotta leave it this way.
That makes sense.
Wait, can we do this something that you can't?
Yes. Yes. That's I'm exactly gonna do that now. But I'm trying to show you like a shortcut. Because conceptually, it's just another way of understanding it. Okay. So let's do it the way we have been. Cube root of 3 times the cube root of a to the 5th times the cube root of b squared. I can't change this at all. Like, ugh, I'm done with that one. Here, I can rewrite this as a to the 5th to the 1/3 power. So I end up with a to the 5/3, which is just a to the 1 and 2/3, aka a to the 1st, and then a to the 2/3. Here I have b squared to the 1/3, so it's just going to be b to the 2/3. Ah, I can't really change anything.
The other way is so much better.
So this is 3 to the 1/3. I can't do anything. It's just 3 to the 1/3. So the only thing that doesn't have a fraction in the exponent, doesn't have a bottom, is the a. So I pull out an a, and everything else I keep inside the radical. So I pulled out an a, and then I have the cube root of 3, a squared, b squared. So let's see. So exactly. So 5 minus 4 is, so I'll have a p here and I'll have a p here. Because 5 over 4 is just 1 and 1/4. So I have a p out here to the first power, and then I have a p to the 1/4 power because it's inside the 4th root. Well, I just wanted to make sure you understood the actual way of doing it instead of the shortcut, but it's all good. Now, really, the only thing we have left to do is this 162. What the hell is this? Okay. What? Yep.
How did you, I thought we got this canceled out because of 1 to 1.
No, it doesn't. It's not 3 times a third. It's 3 to the 1st. So 1 times a third, 3 to the 3rd. It's not 3 times a third. It's 3 to the 1/3 power. Okay, 162. 2 and 81. 81 is 9 and 9. 3, 3, 3, 3. So when you have a square root, we're looking for perfect squares. Since I have a to the fourth, a quad root, I'm looking for something that repeats 4 times.
Can we not just do like 9 root 3?
No, because it's not just a root, it's the fourth root. Number 6, we have a fourth root.
No, I mean, I know, but like in the prime factorization or whatever, you can't just do like square root of 81 is 9.
The square root of 81 is 9, but the fourth root of 81 is 3.
Mm-hmm.
So we have to find whatever number repeats itself 4 times.
Yep, this number of times.
Is it 3p on now?
So I have fourth root of 2 times the fourth root of 81. We know the fourth root of 81 is 3. So it's going to be 3p times the fourth root of 2p. Because I still have a 2 left over. I have
Oh.
this 2 left over. Because if you take 3 times itself 4 times and then multiply by whatever's inside, you should get back to 162. If you take 3p and raise it to the 4th power and then multiply by 2p, you should get what you started with,
Mm-hmm.
which you do.
Makes sense.
Taking it out, you put to the 1/4 power. Okay. What else should we do? Sure, you guys have like 4 minutes. You can work on homework, or Alex, you can get a head start.